Hi guys, today we're gonna knock out our fifth and final problem for a system of equations in three variables unit. So we have a system of equations in three variables and we are asked to answer algebraically. So please don't start using another technique. Use the substitution or elimination method. So again, a gentle reminder, our first step when it comes to solving a system by elimination is to make sure that the equations are in standard form. For all three equations, we do have the variables on one side and the constant on the other. But as you can see, not all three equations have x, y, z. So that's really messing with my flow. So with your permission, we're going to rewrite the system and then have line up the x terms, y terms, z terms, and then constant term. Do you have to do that? Absolutely not, but that will make it a little bit easier on the eye in terms of making the call what variable to eliminate. Okay, so the first equation, look at that beautiful guy. It has all three variables. The second one doesn't. Let's go ahead, line up the terms. The third one also doesn't. So as pointed out, or as you can see, not all three equations have all three variables. Let me go ahead highlight which variable is missing. So from the first equation, we have all three. The second equation is missing the y. And the third equation, yep, you guessed it, is missing the x. Okay. So how do we solve a system of equations in three variables by elimination? So one, we're going to pick a variable to eliminate. Two, we're going to make two pairs of equations and eliminate that desired variable. Now, in this case, let's go ahead and use the fact that some of these equations have a variable missing. Let's go ahead and use this fact to our advantage. If equation 2 is missing the variable y, it wouldn't be a bad idea to say let's eliminate x. If equation 3 is missing the x, it wouldn't be a bad idea to say let's eliminate the x. So which one should we eliminate? It doesn't matter. I'm gonna go ahead, if I have to choose between x and y, I'm gonna eliminate x, y, because the coefficients are the same, so it's very easy to make them opposite, make one negative. On that note, the coefficients for y are also the same. It's also 1. So I guess it doesn't matter, but I'm still sticking to x only because these are closer to each other, so it will minimize the likelihood of me not writing it down correctly. But yeah, it doesn't really matter. Okay, so let me go ahead tell myself what variable am I trying to eliminate. So I'm going to pair these equations with this equations. The first one, I'm not really going to pair an equation. I'm going to pick that equation that has that x missing. So I'm going to say pair 3 with nothing else. I just want to keep the wording consistent. Okay, so we have y plus z equals 2, and x is gone, just like it said. So we're going to pair 3 with nothing else, and then we're going to pair the other two equations. So pair 1 and 2. Okay, so we have x plus y minus z equals 3, and then x minus 2z equals 1. So we want to eliminate the x from each pair. This one doesn't have an x, so we're good. This one, the least common multiple is 1, so we want the positive x and the negative x. Let's go ahead and multiply that bottom equation by negative 1. Okay, so our new system will give us x plus y minus z equals 3. That one was good. The bottom one, watch those signs. That will give us x negative or negative x plus 2z equals negative 1. Fantastic. So the coefficients on the desired variable are opposite, so we have green line to add the equations. The sum of the x's cancels out or gives us 0 as expected. There's nothing to add the y to. The sum of the z's will give us z, and the sum of the constants is 2. So let me go ahead highlight these. Okay, so we had pair equations. I know it's not really a pair, I just want to keep the wording consistent. Okay, so we have paired the equations and eliminated the same variable. So now what do? Same things we always do, not rule over the world, but we join our equations to create a new system. So we have y plus z equals 2, y plus z equals 2, It's the same equation. If you see the answer, go for it, but I really don't. Okay, so in this case, we are going to focus our energy on this new system. This new system has the variables y and z, so we want to find or solve for y and z so we can then, find x. I'm going to go ahead solve for I want to go ahead eliminate it doesn't matter y. Okay, the least common multiple for both for the y's and the z's is 1. I'm going to eliminate y only because it's the first one. Okay, so we want a positive y and a negative y. Let's go ahead multiply the bottom equation by -1 to get that negative y. So the top equation, we're going to leave it intact. We have y plus z equals 2. And the bottom equation, after we multiply by -1, should give you -y minus z equals -2. So gentle reminder, we wanted to eliminate the y. We need to make sure that the coefficients are opposite so then we can cancel them out. So they're opposite. We have green light to add. The y's cancel out. The z's cancel out. And the constants also cancel out. So again, we were trying to find y and z, but that didn't happen. So again, whether your system has 2 variables or 3 variables, regardless if you're using substitution or elimination, once the variables cancel out, I need you to stop. So I need you to ask yourself, do we have a true or false statement? If we had a false statement, then we would just tell the reader that there's no solution. But since we have a true statement that makes me sad, then this means that the system, you guessed it, has an infinite number of solutions. Is this going to be on the test? Of course it is. Okay, so let's do this. So we have an infinite number of solutions. So let's go ahead and introduce our parameter. Introduce a parameter. Parameter is pretty much a new variable that can take any value. So I like to pick u, but check with your instructor. So our parameter or new variable is u. So we need to write x, y, z in terms of this parameter or this new variable u. So what I like to do, I like to take the system that we had in 2 variables and pick any of the equations. They're the same equations, so I just pick one, this same one. So let's go ahead, take y plus z. What was it? Y plus z equals 2. And then we want to put a love note. I'm going to say solve for whatever we have. It's plus 2. Solve for y or z. It's really a personal choice. I'm going to go ahead solve for y just because I'm used to solving for y, but you can solve for z. The expressions will look different, but it's okay. It's the same exact answer. Okay, so if we solve for y, that will give us minus z, and that will leave us with y equals negative z plus 2. Okay, so now let's go ahead formally introduce our parameter. So we're going to say let one of these guys represent u. Let either x, y, or z equals u. It doesn't matter, but this is how I make my call. Notice how we have y equals something. We already have a nice expression for y. So my recommendation is for you to let z, this other variable, equal u. So we're going to say let z equal u. Remember, ultimately we want to write x, y, z in terms of u. We already have z in terms of u. So let me just go ahead highlight this. Let's go ahead quickly write y in terms of u. So we have y equals negative z, but we're going to substitute z for u. Okay, or with you. And me, haha, dad joke. Alright, so that's it. We have an expression for y in terms of u. Let's go ahead highlight that. So we have z in terms of u, y in terms of u. We need to find x, or write x in terms of u. Okay. So I'm going to say find x. So we're going to take any equation involving the x. It could be one of the original equations. It could be one of the revised equations. Let's go ahead, come up. I like this bottom one, but it doesn't have an x, so it's a toss-up between 1 and 2. Do I want to work with with 3 variables or 2 variables? Yeah, 2 variables. So we're gonna go ahead and use the x minus 2z equals 1, or the second equation. Okay. So from that original second equation, we have x minus 2z equals 1. We're gonna have to insert whatever z equals. Z equals, oh, just u. Sorry. Z equals u. Okay, so we have x minus 2 times z, which we're going to swap out with u, equals 1. Work your magic, solve for x, isolate the x term, and that will give you x equals 2u plus 1. So we did it, guys, we did it. We have expression for x, y, z in terms of u. Let's go ahead and get our full credit. So remember, we need to go ahead write our answer in set builder notation. So we need to build the set. Okay, so we have the set of all ordered triples of the form 2u plus 1, negative u plus 2, u. Okay, so ordered triple, so x is 2u plus 1, y is negative u plus 2, and z is u. So we have the set of ordered triples. You can read such that, but we don't write such that, we just put the vertical bar. What's so special about u? Such that u is any real number. Such that u is any real number. Okay, guys, so I owed you, I said that we were gonna do 5 problems for systems of linear equations in 3 variables. This was the 5th and final problem. I think you've had enough of my lovely voice, so we're good to go. Thanks.